Okay, good evening, Bearcats. We're on 2.3 polynomial and synthetic division, but tonight we're actually going to talk about long division. You can see here a lot of our words are about long division. We're going to use long division to divide polynomials by other polynomials. Just a little refresher back from your third grade years when we used to do long division. Let's talk about that just a minute. What if I was dividing 37 by 2? This is old-fashioned division. You would think, how many times 2 goes into 3? Or you might think 2 times what gets me close to 3. So it goes in there evenly once. Then you would multiply back down. 1 times 2 would be 2. You put a placeholder for the 7, and the 2 you're actually going to subtract. So you have to think, I'm subtracting that number. So you put a placeholder for the 7, bring down the 7, bring down the 1. Now you have to think of how many times 2 will go into 17 evenly, and that would be 8. 2 times 8 would be 16, but you'd be really subtracting 16, and that would give you a remainder of 1. And we used to write it remainder of 1. So that remainder is 1, or 1/2 would have been our real remainder. That's just old-fashioned school, third grade, long division, and what we're doing now is the same thing, except we're doing it with polynomials, so it seems a little more complicated. I'm going to erase this, so you might want to pause and write it down or look at it again if you need it before I go on, just to clear up the screen a little bit. Alright, let's move on. Alright, so let's take a look here. We have a long division problem, and we're going to divide 6x cubed minus 19x squared plus 16x minus 4, and we're going to divide that by x minus 2. I'm going to kind of go through this slowly, and then we have several more examples that we'll do. So I'm going to set up just like old-fashioned division like we just had. So it'll be 6x cubed minus 19x squared plus 16x minus 4, and we'll be dividing by x minus 2. Alright, you're going to look at the first term in the binomial, and you're going to think x times what gives me 6x cubed. You would need a 6, and you would need x squared. And then just like we did before, we're going to multiply back. So 6x times x is 6x squared, 6x cubed. You also have to keep going. So 6x squared times negative 2 would be negative 12x squared. You're going to write down negative 12x squared. Now remember a while ago, when you write this down, you were actually subtracting. So we're going to subtract both of those terms, which means both of their signs would change. All of a sudden this becomes a negative and this becomes a positive. Then you're going to draw your line and you're just going to add down like we did a while ago. So these will always cancel. You have a negative 19 and you have a positive 12, so I believe you have a negative 7x squared plus 16x minus 4. Alright, let's keep going. So the next thing you need is you have x times something gives me negative 7x squared. So you need a negative 7 and an x, so minus 7x. 7x, negative 7x times x is negative 7x squared. Negative 7x times negative 2 would be positive 14x. But be careful, we're going to subtract, so we have to change all the signs. This becomes a positive, this becomes a negative. Draw your line and add down. The 7x squares cancel. Positive 16, negative 14 gives us a positive 2x minus 4. We keep going until we no longer can divide this first term into our remainder down here. So now we're going to go x times something gives me 2x. That would be a 2, positive 2. And so you're going to have 2 times x is 2x. 2 times negative 2 is negative 4. And don't forget, we're subtracting both. This becomes negative, this becomes positive. And in this case, we have a remainder of 0, which makes us very happy. That also means something else really important we're going to talk about in just a second. Alright, so there is when we divided, that's our simplified polynomial. That also means that x minus 2, which is a factor, which would mean 2, is a root of our graph, or an x-intercept. So there's some other information that we have. Alright, so now look over here to the right. It says from this division, we can conclude that x minus 2, that factor, times the polynomial factor we found, which is another factor, Those multiplied back together would give us our original equation. If we now take the factor that we just found, the 6x squared minus 7x and plus 2, if we take that and we actually factor it out, because we can do that now, it's a trinomial, we would get 2x minus 1 and 3x minus 2. We could do that with a slip and slide method that we've talked about before to get those factors. Now you have 3 factors, which you should have since it was a third degree polynomial, and now you have 3 x-intercepts. You have one from this one at 2, you have one for the second one, which would be positive 1/2, and you have one from the third, which would be positive 2/3. You can take a look at what that looks like on the graph. And that's how that graph would look. We also know, just as a little bit of a review, because it's a third degree polynomial, that the end behavior would be opposite. One side would go up, one side would go down. We know because it's a positive 6 at the beginning, the right side goes up, and that is reflected here in this graph. Alright, let's move on to some more examples. Alright, let's just keep dividing because the more practice we do. Notice also there's some problem numbers. If you're doing this and you're writing this in your notes, these are actually classwork problems that you will not have to do in class. You'll already have them done. So this will benefit you greatly. Alright, so let's set up the old-fashioned division. We have 2x squared plus 10x plus 12. We're going to divide by x plus 3. Alright, again, 3 times something gives us 2x squared. That would be a 2 and an x. 2x, just check it out. 2x times x is 2x squared. 2x times 3 is 6x. Now, you need to subtract both, so that becomes negative, this becomes negative, draw your line. These should always cancel. 10x minus 6, or 10 minus 6 would be 4x. Bring down your 12. Go one more time. 4 times something, or x times something gives me 4x. That would be a positive 4. So 4 times x is 4x. 4 times 3 is 12. We subtract both. Yippee, they both cancel. We end up with a 0 remainder, and we have now done our long division. So a couple things come from that. One, we know this is a root, so we know that one of our solutions would be negative 3. We also know that if we took that factor x plus 3 and we multiplied by 2x plus 4, they would come back, we would multiply them, they would get us back to our original equation. And last, we can take this second factor we found and further factor it, make it 2, pull out a 2, we would have x plus 2, and then we would find that negative 2 was also a root. So negative 2 and negative 3 would be our roots, which are our x-intercepts on a graph. So a lot of information just from doing long division. Try another one. Alright, here we go. This is a little bit harder. 6x cubed plus 10x squared plus x plus 8. Let me also mention to you, if they skip a degree, this was a cube, a squared, first degree, and a constant, there's nothing skipped. But if they skip over, if they went from a third degree to a first degree, you could put a 0 in there for a placeholder. That will help you just line up everything better. We're going to divide by 2x squared plus 1. Notice each time I'm more interested in that first term than anything else. So 2x squared times something gives me 6x cubed. I believe I need a 3 and an x. So 3x times 2x squared gives me 6x cubed. 3x times 1 gives me 3x. Oh, nothing for 10x squared. This is interesting. So we're going to skip over here under the x and write 3x. Now, we're going to subtract each of those. Draw our line. There's a 0 right here now. You bring this down, you still have 10x squared. You have a positive x and a negative 3x. You have negative 2x plus 8. Alright, let's go again. 2x squared times something gives me 10x squared. I believe that would be a 5. So positive 5. Positive 5 times 2x squared is 10x squared. 5 times 1 is 5. That's got to line up under the 8. And we subtract both. Cancel this one. Bring this one down. So you have a negative 2x and a positive 3. Now this is where it gets interesting. I really can't evenly divide 2x squared into 2x. This is a lower degree term. So we are done dividing, and this becomes our remainder. How we're going to write that now is, since this is a negative, you're going to write subtraction, and then you're going to write the remainder 2x plus 3 over the divisor, which was 2x squared plus 1. And that will be our long division answer. Not too bad. A while ago, remember when we had the remainder of 1 and we put it over 2, so we have 1/2 as our remainder? It's the same principle. All right, last problem of the night. Again, these are homework or classwork problems. This will just save you some time. All right, we get a little more complicated when we skip over to 69. But it's not really. It looks complicated because it's in a different form. But you're still dividing. Remember, these fraction bars really mean division. So you're still going to set it up as 4x cubed minus 8x squared plus x plus 3. Ooh, one thing I forgot. Oops. One thing I forgot. We need to talk about restrictions. In this denominator, remember our restriction would be positive 3/2 because a positive 3/2 would create a 0 in the denominator. So just remember that x cannot equal, in this case, positive 3/2. That's really, really important. Let's go back and just make sure nothing was a problem before. Since we didn't end up with a 0, I think we're okay here. The one before, negative 3, x could not equal negative 3 would have been a problem. And there's a negative 3 right here. So remember that this would have been an issue for us. This would have been an issue for us. We'll talk about that a little bit more in class. All right, let's move on to our last problem again. So you're going to write our restriction just so that we have that. So we're going to divide by 2x minus 3. So 2x times something is this 4x cubed. That will be a 2 and an x squared. 2x squared times 2x does give us 4x cubed. 2x squared times negative 3 gives us negative 6x squared. So negative 6x squared. Don't forget, we're going to subtract both. This becomes negative. This will become a positive. Draw your line. These cancel. Negative 8, positive 6 gives me a negative 2x squared. Bring everything else down. We have plus x plus 3. 2x times something gives me negative 2x squared. That would be a negative x. Negative x times 2x is negative 2x squared. Negative x times negative 3 is a positive 3x. And don't forget, we're going to subtract everything. This becomes positive. This becomes a negative. These cancel. Positive x, negative 3x gives me a negative 2x. This is plus 3. Now, 2x times something gives me negative 2x. That will be negative 1. There's our trinomial. So that now is going to be negative 2x. Negative 1 times 3 is a positive 3. Oh, yippee. It looks like we're about to have a party guy. All right, so this is going to be change both signs because we're going to subtract positive and negative. We get a 0. Little party guy comes out. That's a happy moment. This is now our division. So we do have, this is a factor, therefore 3/2 is also a x-intercept. In this case, it's actually going to be an asymptote because of the restriction in the denominator. All right, I think that's all for tonight. Make sure you have your notes. Tomorrow in class, be prepared to continue to work on these problems, and you'll have a few of them done. Hopefully you have a good evening, and hope your PSATs went well. See you tomorrow. Night, Bearcats.